Case study: Enhancing Cybersecurity, Technova's innovative use of natural language processing for phishing detection. Phishing attacks pose a significant threat in the realm of cybersecurity, with attackers continuously refining their techniques to deceive individuals. At Technova, a leading cybersecurity firm, a recent incident involving an elaborate phishing scheme prompted a comprehensive investigation led by the Chief Technology Officer, Dr. Emily Carter. The attack was sophisticated, utilizing emails that mimicked internal company communications, thereby evading traditional detection methods. This incident highlighted the urgent need for advanced solutions, specifically the integration of natural language processing into their cybersecurity arsenal. The phishing emails in question were meticulously crafted to resemble communications from Technova's HR department, requesting employees to update their personal information. Despite the apparent legitimacy, subtle linguistic cues hinted at the deceptive nature of these emails. The team's first step to employ text classification techniques to distinguish between phishing and legitimate emails. But one critical question emerged: what features should be prioritized in training the machine learning algorithms for text classification? The investigation revealed that word frequency, syntax, and semantic content were pivotal. For instance, phishing emails often contained abnormally high frequencies of urgency-related terms such as immediate, urgent, or important. Utilizing these features, the team developed a machine learning model that analyzed these linguistic patterns. According to Sahin et al., such NLP-based text classification models markedly enhanced phishing detection accuracy, corroborating Technova's findings. Beyond text classification, the team integrated named entity recognition into their detection system. NR identifies and categorizes entities like names, organizations, and email addresses within the text. This technique was crucial in recognizing the context and intent of the phishing emails. A suspicious email, for instance, might claim to be from Technova HR. By cross-referencing this entity with their database, inconsistencies were identified, flagging the email as potentially malicious. What added value does NER bring to phishing detection that text classification alone might miss? Barreno et al. Found that incorporating NER into phishing detection significantly increased the detection rate by identifying deceptive content not easily noticeable through text classification alone. This was evident when Technova's system flagged emails that contained slight variations in the spelling of well-known company names, a tactic often used by phishers to bypass simple keyword filters. Sentiment analysis further bolstered the phishing detection framework. Analyzing the emotional tone of emails revealed that phishing messages frequently employed tactics of urgency, fear, or persuasion to manipulate recipients. By evaluating the sentiment, the system could flag emails that exhibited these psychological tactics. For instance, an email stating, "Failure to update your information immediately will result in access suspension," triggered the sentiment analysis tool. How effective is sentiment analysis in isolating phishing attempts compared to other NLP techniques? Bergholz et al. Demonstrated that sentiment analysis played a crucial role in early phishing detection by identifying psychological manipulation efforts. Technova's implementation showed that emails with a high urgency or fear score were more likely to be phishing attempts, thus providing another layer of defense. Training these sophisticated machine learning models necessitated large, high-quality datasets of phishing and legitimate emails. One challenge Technova faced was maintaining an up-to-date dataset to account for evolving phishing tactics. To address this, they employed transfer learning, wherein a model pre-trained on extensive general datasets was fine-tuned with specific, domain-relevant data. But how does transfer learning enhance the efficiency and accuracy of phishing detection models? Sachs and Berlin illustrated that transfer learning significantly improved model performance, allowing Technova to achieve higher accuracy rates with less training data. This approach not only accelerated the training process, but also ensured that the models stayed relevant in the face of rapidly changing phishing methodologies. Integrating NLP techniques with network analysis provided a holistic view of potential threats. Network analysis scrutinizes the relationships and interactions between entities, such as email addresses and IP addresses, revealing suspicious patterns that content analysis alone might miss. How does combining NLP with network analysis enrich phishing detection strategies? Jagotic et al. Showed that the combination of NLP and network analysis offered a more comprehensive solution, identifying both content-based and network-based indicators of phishing. For Technova, this meant that emails from newly registered domains or those with unusual sending patterns could be flagged for further scrutiny, enhancing their overall phishing detection capabilities. Despite these advancements, Technova acknowledged the challenges posed by the dynamic nature of phishing attacks. Attackers are constantly modifying their tactics to evade detection systems. What strategies can be implemented to ensure that NLP models remain effective against evolving phishing techniques? Continuous research and development are essential. Technova's strategy involved regularly updating their models with new data, conducting adversarial training to anticipate and counteract new attack vectors, and fostering collaboration with other cybersecurity entities to share insights and advancements. By staying proactive, they aimed to keep their detection systems robust and adaptable. Ethical considerations also played a crucial role in the development and deployment of NLP-based phishing detection systems. Ensuring user privacy and data security was paramount. How can organizations balance the need for advanced cybersecurity measures with ethical considerations? Researchers and practitioners must adhere to stringent ethical guidelines and regulations. For Technova, this meant implementing transparent data usage policies, ensuring that personal data was anonymized and securely stored, and regularly auditing their systems for compliance. Building trust with users was essential, as was maintaining accountability in their processes. In conclusion, the integration of NLP techniques like text classification, named entity recognition, sentiment analysis, and transfer learning significantly bolstered Technova's phishing detection capabilities. By analyzing linguistic patterns, context, and emotional tone, these methods provided a more nuanced understanding of phishing attempts. Combining NLP with network analysis further enriched their strategy, offering a comprehensive approach to cybersecurity. However, the ever-evolving nature of phishing attacks necessitates continuous advancement and ethical vigilance to ensure the effectiveness and integrity of these systems.